Okay, good morning, everybody. Thank you for coming today. It's my pleasure to welcome Dr. William Rush, who's one of our faculty members in physics. He's retired. He'll tell you a little bit about himself, but he has a PhD in astronomy and physics and University of Toledo. Did I see that? Okay. This event is part of our STEM series, so we do a series of talks about science, technology, engineering, mathematics. And so one of our goals is for those of you who are in STEM areas of study to give you ideas of career paths that you might want to take and ideas that we're thinking about out there in the real world outside of academics. So I want to say thank you to Brian Kurth from Mathematics, who works with the library in organizing these events. And Dr. Rush, thank you so much for your time. Thank you all for being here, and I'll turn it over to you.
Thank you. Hi. Well, good afternoon. Or I guess still morning, huh? All right. That's the absent-minded professor who can't keep track of what time part of day it is, huh? Okay, I am Bill Rush, and a quick background. I got my degrees in physics and astronomy. I worked at a place called the Gas Technology Institute, which is in Des Plaines and focuses on R&D for the gas industry for about 30 years. The last 10 years of which I worked in cybersecurity. And I chaired the committee that wrote the American Gas Association's standard for protecting gas networks against cyberattack. Okay, and my talk this morning is actually a sales pitch. What I would like everybody to do as you go forward in your careers is to think about whatever you're doing in terms of its potential for being attacked. Okay, particularly as you start to move towards the Internet of Things, any one of those things can be attacked, and with varying degrees of importance. Critical infrastructures. By critical infrastructure, I mean gas, water, and electric. Of course, finance is critical. There's a lot of critical things, but of course, working in the gas industry, I focus on the utility things. And we tend to think of cyberattack as, compromising data, erasing things, altering sites, getting passwords, that kind of stuff. But I want to stress the fact that it can have physical implications, significant physical implications. All these systems are similar, gas, water, and electric. You have some source, okay? It might be a lake. It might be an oil field in Oklahoma. It might be a windmill south in Bloomington, Illinois. And they all have spent what are called transmission lines. You get a lot of the stuff and you have to move it. Okay, so in the case of the gas industry, you run pipelines from Oklahoma to Chicago that run at 1,000 PSI. These are it's called transmission. You're carrying a lot of stuff. In the case of electric, they're 100,000 volt electric transmission lines. And then you have to step them down for people, 110 volts for users at home to a few PSI for people who use gas and so forth. And user automation is becoming common. I love my Alexa. I couldn't even live without it anymore. So it's not that hard to turn the light switch on, but I still don't do it. Okay. Cyber attacks can damage critical infrastructure. And gas, water, and electric are considered critical infrastructures. These use something called SCADA, and we'll talk about what that is in just a minute. There are potential attackers. The infrastructure attacks have occurred, significant ones. The implications can be serious. Our systems, of course, are somewhat protected, but I'm going to argue that there are some really serious gaps. So we are at risk of cyber attack. Okay, so SCADA stands for Supervisory Control and Data Acquisition. What used to happen was that you'd have a compressor station along a pipeline between Oklahoma and Chicago every 20 to 30 miles, and there would be people there, and if you needed more gas, you'd phone them from downtown, and then they'd turn up the pressure. Of course, that got to be expensive, and people said, hey, look, we got computers that can do that job. It's simple-minded. And so virtually all the manned systems disappeared. So most gas, water, and electric systems, transmission systems, are controlled by SCADA. These are small computers. They were designed in a simpler time when no one even thought about the possibility of someone attacking one of them. You know, I put it out there. Who'd want to mess with it? Okay, what would the point be? So there was virtually no protection, sometimes not even passwords. There are potential attackers. There are hackers with various motives, which might be anywhere from curiosity to ransom. There are criminals, usually ransom or sale of information. Terrorists who just plain want to disrupt things. Disgruntled employees. You know, I should have been promoted to manager, but I wasn't, and I'm mad, or I got laid off, and I'm mad. And the most frightening one is nation states. Most frightening because they have large amounts of resource, a lot of money. They have access to intelligence gathering facilities, spies, and they have access to infrastructure experts. In other words, if I am the chairman of the Chinese Communist Committee, Communist Party, I can talk to people who run SCADA systems. In fact, I could talk to people who manufacture them, okay? And many of them will do many U.S. manufacturing operations are done overseas, where the loyalty of the person who's putting it together may not be with the United States. And of course, there are combinations. I can use intelligence agents to recruit unhappy employees. So there are lots of ways that you can do this. Typically, people say, why would I do a cyber attack? I mean, if I want to blow up a station, I take a stick of dynamite or a rocket-propelled grenade, flip it over the fence, and I've got it. And it's really pretty, it's pretty clear. Yes, that's, physical attack is fine. Cyber attack may be the weapon of choice for certain situations. For example, I can set it up and leave it, wait till I need it, okay? I don't have to get an agent in place at a particular time. I can strike everywhere simultaneously. If I want to take on, say, 1,000 compressor stations, I'd need 1,000 people with sticks of dynamite to throw them over the fence at the same time. If I set my cyber attack up properly, I can do it whenever I want. I can time it for maximum political or economic impact. In other words, you do something bad to my country, and I can do something bad to yours. The other economic impact, in other words, if I were going to blow up the gas distribution system, I would not choose to do it in August. Okay, winter is the time of choice. You can have credible deniability. Hard to ID the attacker with certainty. People who are real experts in this can usually make a pretty good guess, but you don't want to make a bad guess if you're going to make a counterstrike. And scariest of all is what's known as a cascading attack, where a failure in one system trips over into a failure in another, and I'll give you some examples of that in just a minute. Okay, systems may rely on each other. For example, SCADA relies on a communication network. Take the network down and the SCADA system's useless. Water pumps rely on electric generation. So if I knock out the electric generation as a twofer, I also get the water network. Cell phones rely on the electric grid. Yes, they have backup batteries, but in a typical system, if the electric grid goes down, the backup batteries last for 2.5 hours at normal use. During a major attack, people are likely to get on the phones and pull the grid down much faster. Many electric generators now are getting away from coal and they rely on gas. About 45% of the electric generation comes from the gas transmission system. Traffic control relies on electric. Okay, shut off all the electric grids and the stoplights and the streetlights go out, as do the gasoline pumps. Backups all have lifetimes and may depend on other systems. So a cascade failure is a case where one system's failure trips over and impacts other systems. If you asked me to design an attack, what I would pick is Friday night, 5 o'clock, coldest day of the year. Okay, the executives are in traffic, so we hit the attack the gas and electric grids simultaneously. Homes immediately start to cool. People get on the cell phone. Aunt Martha, have you got heat? The gas traffic lights go out. Somebody in that traffic jam is going to be low on gas, will pull off, try to fill up. will not be able to, will get back on the road, run out of gas. Okay, so now you end up with a jam that's compounded with no gasoline. It starts to get dark. People start to flee to unaffected areas, making the traffic jams worse. It's now very hard to move the repair staff. I want to get a generator out to the cell phone network, but the traffic is so bad I can't. The cell phones go out in 2 hours, the internet gets flooded, vulnerable people may actually freeze to death. And if you can keep this attack running long enough, you get distributed damage because people's houses, the water pipes freeze, and now you have thousands or hundreds of thousands of people with burst pipes, and only a limited number of plumbers in the area who know how to fix them. Okay, this has both an economic and a confidence impact. If your goal is terrorism, to make people feel nervous, this will do the trick. Okay, is this a theoretical possibility? No. The largest and most successful cyber attack was a US cyber attack on the Russians in 1982. I have dyslexia. This was the largest non-nuclear man-made explosion ever. It was photographed from space. The people who saw it first thought it was a nuclear blast. It was very large. And if you want, I just have given you a couple of examples. If you look on the internet, there are, you find hundreds of them. A Turkish pipeline in 2008 was a massive explosion. 200,000 Ukrainian electric customers were out, probably courtesy of the Russians. Again, not easy to tell who did what. But you can look for lots of examples. Okay, obviously people know about these risks, and if you have a system like this, you do want to protect it. Okay, the early systems had little to no protection. There was simply no reason that anyone would mess with them or would even know they existed. Now everybody does use passwords. Depending on where you put the password protection, this is or isn't effective. I have seen some systems where you have to enter, if I have my PC or my laptop, I type in the password there, and it lets me onto the system, okay, onto my computer. However, once I get past that, if I actually get into the network itself, there was no password to keep me off. Not an especially brilliant design, but these things were put together in a much more trusting age. Some people use virtual private networks. There is encryption, which has problems. I think the utility operators tend to overestimate the significance, but it doesn't matter because it's in their mind. Of course, it adds extra cost. If you are buying a new piece of equipment, it is not so much of a problem. If you're retrofitting stuff, that's much more of a problem, and people don't want to pay for a replacement of their entire existing system. They may slow down communications. There is a problem associated with operating an encryption system, which is what's known as key management. In other words, it's sort of like a combination on a combination lock. And I have to distribute the keys to hundreds of technicians. If a technician leaves, then I need to, if it's like a password, I may need to change the password. Well, that becomes a problem, and I don't want an old technician who's been fired and is unhappy releasing the key information. And there's even key management issues within the encryption systems themselves. There is reluctance to accept standard encryptions. Most of the utility executives look at this and say, well, look, if I'm going to make an encryption system, I'm going to have my guys do it downstairs because no one else will know how it works. That's a really bad idea, unless there was the adoption of a standard encryption mechanism, which kind of sounds like a goofy idea. Why would I have a standard encryption technique that I publish? Well, you can look up a combination locks mechanism. It's easy to find out how a combination lock works. The problem is, even though I know how it works, without the combination, I can't open it. So that's the key thing with an encryption, a standard encryption system. And these things have been tested very, very hard. They're open competitions. I want you to use mine, so I publish it, and everybody tries to crack it. And the only ones that survive are the ones that nobody else could crack. Okay. And the other thing is, it's not really perceived as a major risk. You know, if I run a utility, I've really never had a problem with it. So to get me to invest a lot of money in something that some guy comes and gives me a lecture on how you know how risky it is, really doesn't make me grab the checkbook. I had when I was working at the Gas Technology Institute, I had kind of an interesting little experience. We had an electrical engineer intern, and he was only going to be with us for 3 months, and so it wasn't worth a lot of investment in bringing him up to speed. He didn't really know much about the gas industry. So we ended up calling him the cave boy. What we gave him a task, knowing very little about the gas industry, his goal was to design a manual for attacking United States gas infrastructure. And the rules that he was subject to were that all you can do is use the internet. And you want to pretend you live in a cave in Afghanistan, you have internet access, but that's it. And so what we want you to do is to produce a manual that we're going to give out to other people living in this same cave. We're giving them instructions on how to get the information we need for a successful cyber attack. And so he worked for about 3 months on it. The goal was really, you know, see what happens if you think like a bad guy, what can you do? And so he ended up producing an 80-page document with step-by-step instructions on how to attack a gas utility. And it would work, I'm sure, just as well for water and electric. Okay. When you're designing things, if you find yourself in the future working in technology, one of the things I suggest you do is take a little time and do an exercise of thinking, I want to attack this system. What could it do, and how would I do it? And if you've only kind of looked at this from the good guy side, you know, here's how I want to attack. Here's how I want. You know, I take a course in cybersecurity or something like that, and I look at how do I protect the system. You want to think about it from the point of view, now how do I attack the system? Okay, and there's a ton of good stuff out there. If you've never seen the book Secrets of a Super Hacker, it is a very informative system book, particularly because it doesn't worry about day one secrets that are found, just revealed. It doesn't reveal, you know, how to attack the internet by redirecting communications. One of the things that it talks a lot about is something called social engineering, which is one of the scariest techniques. It doesn't matter how good my home security system is. If you have the key, you can get in, okay? And in social engineering, what you do is you just talk to people, or you use clever little tricks to get the information. It allows you to access the system through the front door. And there's one of the techniques is known as dumpster diving. How many people have heard of dumpster diving? Okay, you jump into a dumpster and you pull out everything you can get, and even little tiny clues are helpful. The company that I worked for, one time I was in the stock room and I went out back, and there was a bunch of people rooting through our dumpster. And I talked to the guy who was the dock supervisor and said, you know, what is that? And he said, oh, it's a bunch of guys. They come about once a month, and they go through the dumpster, and they pull out stuff that they can recycle. and then we had a bunch of computers that were ready to go into the dumpster. I mean, so, you know, they got the hard drives in it, the whole shot. So that's social engineering. That's okay. There are hacking disks. You can buy these things. I would caution you, if you're going to try to do some of this stuff, be kind of careful, because the people who are willing to give you hacking software themselves are good at hacking, and you don't know that their souls are pure. They probably are, but maybe they'd like access to your computer. But anyway, there's all kinds of these things that you can buy, and there's on the web that you can just download the software. I had a lot of fun with this when I was first doing it, but I didn't really understand some of the risks. But anyway, all right. There often are what are known as undocumented commands. In other words, I design the system and I put some security in it and so forth, but I recognize that I may sometimes need to service it. And so I want to get into it without going through all the passwords and everything else. So I put in a back door so that I can just access it and see what's going on. And that, of course, we don't put that in your manual, but somebody in your company knows about it, and there's a good chance whoever manufactured it knows about it too. So there may be back doors that are not listed. There are ways to bypass password protection. It is possible once you get into the things to reprogram them. They may allow logs to be altered. And these are easily found by, if you want to work with one of these things, you can buy a SCADA unit from a manufacturer for a few $100. You get the manual, okay? And of course, you can reverse engineer the thing too. So there's a lot of stuff that can be done. Let me just, we tried an exercise at GTI where we had one of our engineers write attack software for a SCADA unit, and it was a under the radar exercise. Nobody in the company wanted to fund somebody doing something useless like that, but he, in a matter of about 2 days, got a pretty scary set of capabilities. One of them was that the SCADA unit was modified so that it reported a pressure that appeared to fluctuate. What he did is he recorded the last 4 readings, and then when you interrogated it, you just were cycling through those 4 readings. So if you looked at what was going on, kind of looked like the pressure is fluctuating back and forth at random. He then fed that information into the control room. At the same time, he shut down the valves and all the alarm systems. He was able to fix it so that if you started to search the software for this to see if you'd been hacked, it erased itself. So there were all kinds of ways that this was a pretty nasty kind of attack. And I tried to get people to adopt a program where they went through and looked at their own software to see if it had been hacked. And I never got very far with it. No one seemed to want to do that. Okay, but you can reprogram these things if you're clever enough. A typical attack would be to run the pressure too high, disable any safety routines, open and close valves, and send false data while the hacker is in control of the system, so you don't know that you're being attacked. One of the things that's just a simple attack is change the password, and not once you're inside the unit, you change the password, and then the security that's designed to keep the hacker out keeps the operator out. So so the attack protocol that we did was it was easy to implement. It had step-by-step instructions. You only needed the internet. There was a list of the sites that you should visit and what to do with the information. Now, this does require patience. Well, of course, a lot of hackers have, one thing that they all do have is patience. And it relies on the accumulation of lots and lots of small clues. And people are constantly telling you, oh, well, you got to be aware of, in fact, this is what, Cybersecurity Awareness Week or month? Month, okay. How many people keep their, your password's supposed to be changed frequently, it's supposed to be hard to remember, so what do you do with it? You write it on a little piece of paper and stick it in your top right-hand desk drawer, okay? Just, if you are visiting somebody's office and you can, one technique is you have somebody phone you and you say, oh no, hon, is that, oh no, this is terrible. Could I just have a minute, please? Jeez, I'll be, just a minute, okay? Well, he steps out and I go to his right-hand desk drawer, okay? So that's an example of social engineering. Okay, and lots of little clues. I don't expect to get the complete system map in one place. And so you give me a little tiny piece of useless information. Old memos, addresses, old passwords in dumpsters, that kind of stuff. You just pick up all kinds of little stuff. And intelligence agencies are excellent at this, especially if you have an intelligence agency, a cyber warfare group that's upwards of 10,000 people, which when you look on the internet, I've seen estimates for what the size of the Chinese cyber warfare group is that range from 10 to 100,000 people. I think the 100, they're not going to tell you, right? But at least there's folks who think that it's a pretty, and it is part of their military doctrine. It is considered, they say it's fair game to do cyber attacks. We clearly have the same opinion, okay? I mean, we the biggest cyber attack ever done, the most damaging one was one we did. And there was Stuxnet where they attacked the Iranian nuclear program, the Siberian pipeline explosion where they blew up the largest non-nuclear explosion as mankind's, man-made. Okay, so anyway, what we did at the end of the summer after our Cave Boy, Cave Boy was really, he's a very nice guy. He's now got his PhD in math and he works up in Madison, Wisconsin. But at the end of the time, as his graduation project, we had him take a particular gas distribution system, and I'm not going to tell you which one, and spend 16 hours to see what happens. And so I have some screenshots and of what it looks like, the kinds of information, small pieces of information, things that you would think make a lot of sense to make public. It's convenient and useful. And of course, a real attacker would have much more time than this, access to much more resource than he did. But the key is patience and accumulation. We did not allow him to do any social engineering, although he sort of wanted to, against this company. But I gave this talk to people who really run pipelines, and I'm pretty sure one of the people that was in the audience was the company that we happened to have chosen. And I got a call from the vice president of operations. I wasn't there. It was in my voicemail, and I thought, oh crap, am I in trouble? Because one of the people said, hey, that's my system. And he went and talked to the VP of operations who called to say thank you because we didn't realize that we had this much out there. We're going to go and close it up. But all right. Okay, storage. This is an actual, it's a web, it's just a screen print from this company. They store natural gas. You can't, if there's a shortage of gas or if there's an interruption in the pipeline, they store it in underground old water aquifers. So here's a description of how much is there. Of course, you don't know where it is from this. But at least you know it's about how much is there, and you can predict if we know how much gas you use in a day, how long would 150 billion cubic foot supply last you, and if you find that that's objectionable, then you want to plan to take that storage field out of operation by shutting down its compressors or whatever, so you can help figure out what's going on in the system. Okay, this is enough to meet 1/2 of a day's delivery. So. If you fail to get this, the gas company can pull out a half day's worth of supply on their coldest day. And it stores about 1/3 of normal winter. And it's located near City C, whatever that city is. This is the phone directory, which allows you to get access to people's phone numbers. So it's important, for example, if I am the vice president of operations and I want to send a text to somebody telling them, for example, we are under cyber attack and the FBI has instructed us not to make any counters because they are trying to catch the bad guys. So you will be fired if you try to stop the cyber attack. And it's coming from the VP of operations cell phone. I chose a time when I know he's out of town, so you can't easily verify it. Okay, so we got the list of street addresses of all the facilities. So I now know where I can now match the street address up against the storage station address and against any other facility that I find. It lists phone numbers. There's something I don't know. Do people use war dialers anymore? Okay, a war dialer is a machine that dials all the numbers in, 1111, 1112, 1113, 1114. The people who do the telemarketing use them, okay? And what it does is you turn it on and you operate it overnight, and it checks to see if I have if somebody answers, or if what picks up is a fax is a modem. Because now if it's a modem, there's a good chance that this is some kind of a remote controlled operation. Okay. The contractors who provide you with SCADA systems, who provide the services, of course, want you to know that they're out there. So they advertise, I serve this many companies, and here are, it's Chicago and New York and Los Angeles. So you now get information about which companies are being served by which contractors. And this provides it indicates that it is the site of a SCADA master controller. So now I know the manufacturer of City C's cyber equipment, their SCADA system. I know which one of the manufacturers it is and which one I have to buy and reverse engineer. It indicates that this operates on something called spread spectrum radio, which is a system that's hard to get in because the frequencies jump apparently at random. So it's sort of like you're trying to listen to a news broadcast that's on First News Radio 780, and then it goes to 620, then it goes to 490. It just keeps jumping around. And if you don't know the sequence of jumps, you don't know where to change the channel. We know that it uses we know that it carries current readings, alarms, and data. The data goes to something called a GE Simplicity controller. It uses Intolution iFix hardware at the control center, and it has on-off control of pumps. Okay, that comes from the contractor's site. Again, I'm trying to pick up, I'm trying to put all these pieces together so I know what I'm looking at. It uses Ethernet multi-drop communication networks, and there's lots of interesting stuff. And in fact, I now discover that not only City C, but also City E underground storage facilities use this same stuff. Okay, uses a 902, there's a radio it uses. The radio stations are located 5 miles apart. I know how much City E's gas controls, and that there is an alarm for loss of communication, which I need to disable. The Simplicity Manual is online. It includes the default password, so that, now of course, if you only change your password once, do it the day that you start the thing and take the default password out. If you don't, the most common password, of course, is password. So that if you're trying to hack a system, that's your first guess. Okay, there's a bunch of manuals. These are made by different controllers. These are all manufacturers of SCADA system, and these are the chapters where they include discussions of their security systems. This is a United States Geological Survey Map, and it shows the pipelines. Okay, there's a pipeline. One of the secrets of the approach is that you take the map of the city you want to attack, take a compass, draw a circle all around it, and follow that circle. And each place that circle is cut by a gas, water, or electric pipeline, you have a potential target. You now move along the pipeline until you find the storage facilities, the compressor facilities, what you need to know. Commercial maps are helpful, and these include this is an actual map. Now, unfortunately, I had to black out the whole map, because if you saw that section, you'd know what city it was. But it lists where the chemical plants are, fractionators, underground storage, communication hubs. The whole network is laid out for you rather nicely. Of course, Google provides you with aerial photos. And if you're not an expert on things, you can at least look. These little fine lines here are a person even modestly skilled in gas operations realizes each one of those is something used for measuring flow, and the more of them there are, the bigger the station and the more important it is. We found the location and frequencies of the radios, 12 gas turbines with horsepowers in them, 6 gas engines. And so this is all pretty easy to gather. We did a malevolent code that could change set points, could change the safety limits, and could lie to the system host. You can open and close valves. You can turn equipment on and off. One of the questions to which I do not know the answer, and it is a scary question, I was not able to find out, is it possible to damage a compressor? It is possible to damage an electric generator. The reason that you want to attack these electric generators or compressor stations is that these are big pieces of equipment. They're very expensive, and they are manufactured, say, at the rate of one a month. So if and there will typically be one or two in inventory. So if I destroy, say, 3 of them, it's going to be a month before you can replace the 4th one. If I destroy 100 of them, it's going to be a long time before you can get the system fully back up again. I do not know if it is possible. The turbines are complicated machines. They have a lot of mechanical protection, but increasingly people rely on electronics. I have an electronic sense, typically, in the old days, when you had a gasoline engine in your car, there was a pedal you pushed on the floor, and it turned a valve that let gas into the engine. And there were mechanical safety things. Nowadays, you drive by wire. You're actually pressing a sensor, and that tells the engine how fast to run. The old days, these turbines had mechanical protections. Many of them seem to be going to electronic, and if you're ever designing equipment with electronic safety capabilities, please think about, can somebody shut them down, and what happens if they do? Okay, so here are, I guess this is just an argument that I made to people. That the bottom line, that Cyberattack is impossible, is an indefensible position. We had the U.S. government attack on the Soviets, the Soviet oil pipeline. What they did was they closed the valves to the system and then cranked the pressure up. And they cranked it up high enough that it broke the pipes. And it was a 3 kiloton explosion. Hiroshima was somewhere between 14 and 21 kilotons. The Oklahoma City bomb was 0.01 kilotons. Okay. If you talk to people in the area, you will find that there are a lot of reasons not to worry about protecting your system. Number one, pipelines are unattractive targets. Terrorists want to hit, government facilities, blow up the Statue of Liberty, blow up the Pentagon, blow up the White House, but the pipelines are just not very attractive. They're not sexy. SCADA systems are obscure. Nobody knows about them, okay? So who's going to attack something you don't even know about? We have physical safeguards that protect our equipment. And a cyber attack can't do physical harm. Well, I hope at this point you're convinced that this is, these are not valid safety protocols to have in place. So SCADA cybersecurity is often an orphan. IT folks focus on the corporate network and internet corporate security. The physical security people don't worry about the electronic stuff because it really can't hurt them anyway. And that's the job of the IT people. The SCADA people rely on obscurity, and few people actually watch SCADA systems and SCADA networks from the perspective of cybersecurity. Okay, my conclusion, cyber attacks are feasible. Motivated attackers exist. The attack information is accessible. The consequences could be significant. I don't want to take a position on whether or not an attack will occur because, I don't know. Maybe we'll never have a big one. Pressed, I'd say I'd kind of be surprised if somebody didn't do it. One of the things, if I were designing a system, an attack, I would not make a little attack. The Japanese didn't fly one bomber over Pearl Harbor. You want to attack in force unexpectedly. And that there are a bunch of myths that I think create false security sense. And I've been in meetings with people and say, we really need to up the ante on this. And I hear a lot of these myths, and we're just not vulnerable, or we're not interesting. Okay, we managed to finish to give ourselves about 10 minutes for questions, if anybody has any. Or else I'll say, wow, that was a brilliant talk, and I answered all their questions at once. Yes?
In your role, were you able to implement anything
Not really. We were an R&D organization. We could be, it's sort of, I can lead the horse to water, but I can't make him drink. We did put together what we thought was a very excellent protocol for protecting them. It's still online. It's called AGA, American Gas Association report number 12, and there are 4 pieces to it. And it's pretty comprehensive, but like I said, you can lead the horse to water. Yes, sir.
Besides, do you know of anything that could damage like major infrastructure? Like, do you know of any other major attacks besides the Soviet pipeline?
Yes. The question was, are there other attacks besides the Soviet one, or did we just get lucky on that one? And the answer is yes. There was an attack in 2008 against a Turkish pipeline. This was not a gas pipeline. This was an oil pipeline. It was the same technique. You get in, shut all the valves out that let the oil flow out, and crank the pressure up. These things are designed. The system is designed to withstand that. In other words, it is. You think about it, if I'm designing a system, it just doesn't make sense that I could actually break my own pipe. So in theory, an engineer will say, yeah, and the people who will talk about physical protection say, well, the system is designed so that if I shut it completely down and turn the pressure all the way up, the pipe won't break. And that was true the day it was built. The problem is the pipes are typically buried underground. Once in a while, it'll get nicked by somebody who's digging near it, which is why they tell you to call before you dig. Corrosion can take place. There's a lot of, you can have geological shifts that put stresses on the thing. And so the pipeline, while it originally probably certainly was strong enough to take the pressure, it isn't, in typical cases, it's no longer the case. Let's see, the Ukrainian one was not a burst. The Ukrainian one was they simply shut all the valves. And then the people who were operating the system couldn't figure out how to get them back up again. Well, I mean, they did, but they were like 2 days without electric power. Guys in California apparently would be glad to have only 2 days without power, but okay, anybody else? Yes?
Do you know many times where something like this happened, like in America, not America,
To the best of my knowledge, there has been no physical breaks due to a cyber attack. However, there was one against 4 companies that operated a combined hub where people hacked into it. And that was just a couple of years ago. I can't remember what it was. Okino was one of the companies. That was maybe 2012 when the system was hacked. Those are the only ones that I know of offhand. If you go to the internet and look for cyber attacks against U.S. pipelines, I'm sure you'll find others. Yes. Okay.
do you think anyone will actually try and fix things before something actually
Oh, sure. Well, I mean, people are. I mean, there are companies out there that manufacture protective equipment. The people who run these big companies, maybe I've been a little unfair to them. I mean, they're certainly not stupid. And they recognize that there is some level of risk. If I wanted to do a really, really good thing, I would hack into a system and do some damage, not hurt anybody, but enough that people would say, oh gosh, maybe we better pay more attention to this. But sadly, I suspect a really, really serious upgrade of the security will probably not happen until, it's close the barn door after the horse runs out. Hopefully it won't be a big piece of damage. Somebody will blow. I mean, the Stuxnet attack kind of sneaked out by accident. Nobody meant it to get to where it got, but that certainly raised people's awareness of what you can. And if you haven't ever heard of Stuxnet, it's worth looking that one up on the internet too. That's really that's really an eye opener. Yes. Yes. Yes, and in fact, one of the things that if you wanted to attack them, one of the things that you look for is a boast that says our technicians can fix our equipment from home. Because what that tells me is that it's probably hooked up to the phone network, okay? So a war dialer would be a good toy to use there. So yeah, there are a lot of things if you kind of just know a little bit what looks like a harmless piece of it. You know, yeah, it sounds good. You can fix it from home, but what that means is somebody can get it. You can probably get there too. Okay, anybody else? Yes.
You mentioned you have a PhD in physics, is that accurate?
Yes.
Okay. How did you make that pivot to cybersecurity? In the last 10 years of your career?
Well, yeah. Well, actually, one of the things I tell the students in my physics class is that you know, who wants to take physics, right? It sounds boring and hard. One of the comments that I make is that you probably have a 40-year career ahead of you. Given what the internet, or given what Social Security is doing, and maybe a lot longer than that. And during that time, I'm pretty willing to bet that you will see two major changes in technology. And that technology will change. The basic physics that underlies it won't. And actually, I taught for 5 years, and teaching turned out to be a hobby that I couldn't afford. So I went to work in the gas industry, and they were working on a solar air conditioning system. They said, well, you're an astronomer, so you know where the sun is and all that kind of stuff. And so I went to work on solar air conditioning systems. You know, when the sun's shining, you got what you need. Well, that didn't work out real well. And then I ended up using math. You have a strong math background, so I worked in coal, the other side of environmentally clean. Then I got involved in gas distribution, which is how you move the pipe, move the gas around through the big lines and the little lines, and automatic meter reading. I was one of the 10 founding members of the Automatic Meter Reading Association, which is now the smart meters, and we developed standards for that. And then as we started looking at it, we realized that these systems were hackable, and so I started working in that, and I published an encryption mechanism. I didn't make the mechanism, I just found it. It was something called RSA, which turned out not to have been a good choice. But anyway, I recommended that, and nobody took it. And for about 8 years, nothing happened. And I went other ways. And then there was 9/11, and I was checking into a hotel for a meeting, and somebody grabbed me and said, you got to come with us right away. We need security. And man, the funding flowed for about 4 years. And then forgot. So that's kind of how it evolved. So I'd be very surprised if whatever you think you're majoring in right now is where you end up. Like you said, it's a long way from teaching astronomy to cybersecurity. Yes?
So as everybody goes through STEM, right, they come through portions that they don't enjoy or find challenging and feel like they should switch. What piece of advice do you have for students going through these challenging STEM programs with things becoming more and more complex and more interconnected, right? For example, you have to learn about technology, cybersecurity, and the gas industry, and your physics background coupled together and coming together.
Oh, I'd say if it's hard, quit. No, yeah, no. I mean, I had my share of courses that I didn't want to take. I can't think, and this included stuff like literature and and accounting and business management. I did get an MBA along the way too, which I thought were really bad, and especially when it talked about people and stuff like that, which no equations for people. But I can't think of a single course that I took that I haven't used at some time or other. And you'd hear about, oh well, here's I don't know, there's the Taylor series expansion, which never used it. Doesn't seem like anything good. Well, suddenly you get into quantum mechanics and you realize that oh, that's why that was there. So there isn't much that you don't need, or at least that you won't use. Now, oftentimes you can learn it later, but you do have to take courses you don't want to take. But you know, you probably need them sooner or later. Somebody thinks you need them, and you'll probably find you did. Okay. All right, I'm 1 minute over my time. Okay.